up with the what's up? It's your boy, Mr. Ellis, coming at you live, but not actually live because I'm recording this thing not when you're here. Ready for an exciting math lesson on functions. Are you ready?
Yeah!
You are? That's awesome. Thank you for participating and yelling out, yeah, really loud. I'm sure that you did that. Okay, so real quick, write this down. Pause the video if you need to. Ready? And pause. Why did I put my hand over it when I said pause? That was so dumb. Ready, pause. There we go. And hopefully you're back. Okay, so I just wanted to make sure that you had this little chart written down. I think it's kind of helpful for us to be able to remember that these words are all parts of individual groups, and it's important that you know the difference between those groups. So X values are always referred to as
input values. The domain values are independent variables.
These always kind of are kind of like synonyms. They mean slightly different things, but they're all at least part of the same grouping. Whereas Y values are sometimes referred to as
output values, range values, or dependent variables.
The X values, these are the things we put into a function. The Y value is what we get out. You may want to make a quick note. When I say output, it's also like another way to think of it is the word answer. It's like the answer that you get. This is like what you put in. This is what you did. This is like the result, the output, the answer. Domain is a listing of all the X values. A range is a listing of all the Y values. Remember, on a graph, they go side to side, up and down. And then this is like science class. So I don't know if we've talked about this much or if you've talked about this much or whatever, but independent versus dependent variables. Think about what these words mean. If you looked up the definition of independent versus the word dependent. Independent means like, you're a strong, independent woman. You don't need no man. I don't need my mama taking care of me. I'm independent. I can do my own thing. You don't rely on other people. You have complete control over your life. I am an adult. I am independent. I love my parents. They're sweet people. But I don't need them. I do my own thing. They don't tell me what to do. My dad doesn't tell me when to wake up. I do that myself. Independent. X values are independent because we have control over them. We choose what we're going to use for X values. Whereas Y values are dependent. They depend on the X value. So whatever you get as your answer will depend on whatever you put in as your thing you put in. It's like a seahorse. They're dependent on the current, right? They just float around in the ocean. If they want to go over yonder to see old Jill, the seahorse, I hope the current takes them there, or else they can't get there because they're dependent on the ocean. They just kind of float around, and wherever they end up depends on wherever the current took them. They don't have control over themselves. That's a weird example, but it's what I used. Independent, dependent. Got it?
Yeah!
A couple other things that you may want to write down real quick. Functions can also be represented by an equation. That's kind of what we're focused on for today. See? Remember, equation means we're always going to be dealing with equal signs. That's what equation means. Equals. You'll also see that written, by the way, as a rule, like a function rule. That's the same thing. Anytime you see that, it just means equation. It's a really weird way to say it, and it's annoying that people do, but some people like to do that. And that's, you know what? How dare I call them weird? That's fine. They can do whatever they want. I just think it's easier if we just use the equation word instead, but that's fine. The equation will generate, write down this guy, ordered pairs. Ordered pairs like these guys. To blow your mind for just a second, it's called pairs because there's two of them, and they're ordered because the order matters. There's the X value and then the Y value. What? Now you know why it's called that. You didn't know that before, but maybe you did. The equation will generate ordered pairs by taking an input value. Remember, that's my X values. Putting it into the equation or the function or whatever, and it results in a certain output value, aka Y value. And then when you graph these things, I know I'm kind of going quick, but it's pretty easy. When you graph these things, when you put them on a coordinate plane, they will make a line or a curve For what we're dealing with right now, we're going to be dealing with almost exclusively, that's the word I wanted to go with, almost exclusively lines. When we get a little bit fancier next semester, we'll start doing a lot more curves. But for now, we're dealing with lines. So the last little thing here, it says, think of a function like a machine that takes an x value, whatever we put into the machine, it does whatever it's programmed to do, it's whatever it says, you'll see what that means in a minute, and then it shoots out some kind of an answer. Remember, the x value is called the independent variable. I think it's an ENT. I am not positive. It might be an ANT, and if that's the case, I am embarrassed. But I think that's right. It's independent because you pick it. You can put anything you want in here. I can put whatever number for x. I can make x a 5. I can make x a 2. I can make x a 0. I could be really terrible and make it a 1/2. Do whatever I want. I'm independent. But the answer depends on whatever we use. So we can't just pick whatever answer. Like, it's not like you get to choose the answers and whatever you want's right. This is not like moral relativism. This is the opposite of that. This is, you have an answer that you have to get right, or else I count it wrong. Because it is dependent on what we put in. All that to say, let's look at what this means. Pretty simple. You're going to be given an equation. Y equals x plus 4 is this equation. So the function or the machine is an x plus 4. This is programmed to take whatever we put in for x and add 4 to it. That's what it does. Now, I'm going to use the numbers that are given to me because that seems reasonable. And the first thing I'm given here is a -5. So I'm just going to take this -5 and I'm going to plug it in for x. I'm going to substitute it in for x. I'm going to take it and replace the x with that. I just said the same thing 3 times. Hopefully one of those sticks with what you're doing. You're just changing the x to a -5. So if I were to write it, it would look like this. Y equals, let me erase this. If you drew that, I don't care, it's fine. I'm just changing that x. I'm going to put it in parentheses, -5, and then plus 4. So see how I just rewrote it, but instead of an x, I changed it to a -5. I also put it in parentheses. That's just a good rule of thumb, is to do that. It's going to save you once we start doing like x squared stuff, quadratic stuff, x cubed stuff, whatever. When we start adding exponents, this will be a big deal that we put it in parentheses. So it's just a good habit to go ahead and build. And then all we're doing is we're trying to figure out, okay, so with x changed to this, so what does the y have to equal? Well, what is -5 plus 4? And you say, I don't know, because it's negative, and I don't know how to do negatives. Well, dadgummit, you got a calculator, so use it. All we're doing here, nothing fancy. We're not solving for x or doing anything like that. We're just doing a -5 plus a 4. See how I just, oh, you can't see, now you can. I just typed it in exactly like it was. -5 plus 4, -5 plus 4, hit enter. It's -1. Well, shoot. How did you do that? Just magic, I guess. So the answer, when you put in a -5 and you kind of do whatever it says, which in this case it says add 4, so we did that. Our answer was a -1, so I'm going to put that here in the answer column, or the output column, or the y column, or the dependent variable column, or the range, or however you want to say it. And then we just do that again. We're going to do the -4. I'm going to put it over here. Y equals parentheses -4 plus 4. -4 plus 4, that's 0. That's weird. There it is. One thing I want to show you real quick, in case you didn't already know this, if you're using your calculator, you may not need it for something like this, but once we get into tougher problems where you have to you definitely have to use your calculator to figure out what they equal. If you have to do the same thing multiple times, like in this case, we have to do the same thing 4 times, instead of typing in the whole shebang every time, there's different calculators have different tricks. You can scroll up and click stuff. I know some of you guys do that. I always hit second enter, and it just pops it up for me. That's just kind of how I've always done it, but it's up to you. And it just repopulates this, and then you can just scroll back and change whatever you need to change instead of having to type the whole thing in. Again, all we're typing in here is like a +4, so that's not a big deal. But when we get to really long, huge, like cubic functions and stuff, you may not want to have to type in a huge thing 4 different times. So this can save you a little bit of time. So I'm going to change, instead of a -5, I'm going to change it to a -4. Hit enter, and there you go. And then instead of having to type all that in again, I just hit second, enter, and now I'm going to change that to a -2. Right, my x value is now a -2. We're always adding 4, so that's always going to stay there. That's a 2. So this kind of saves you some time instead of having to calculate all this stuff by hand, but you can do that too. You're smart ones. And then one thing that if you don't use a lot of calculators, because you're so smart, you don't need a calculator. You are a calculator. Well, you may not know this. So this gets people in trouble a lot of times. Like, okay, I want to change it to a 0. I want to change that to a 0. So you scroll back and you type in 0, but you still got a 2 right there. You got to get rid of it. If you hit clear, it's going to clear the whole thing. So how do you get rid of just one little piece? Well, that's where this delete button comes into play. So if I hit the delete button, it just takes away whatever your cursor is on and it scoots everything back in. By the way, this insert, the INS above it, if you hit second delete, it does the opposite of that. So if you wanted to add something that's not there without ruining the whole thing, you can hit second insert. I don't know, my thing's messed up, so it may not have worked. It did work. And then it types that thing in wherever that blinky piece is. See, I can just keep hitting 2s, and it just pushes everything out to the side. So that's just a good thing to know. Delete just deletes that one individual thing. So this is a cool button to be able to use. You may not have known that, but now you do, so that's cool. But 0 plus 4, I mean, come on, it's 4. After we do this, then we go over here and we graph it. Remember, these we just created ordered pairs. These are like x, comma, y ordered pairs. Right, we've got 4 different ordered pair of points that we just created. So now we just put them on our graph. You go back 5, down 1. Hopefully you can do this. 1, 2, 3, 4, 5, down 1. You always start from the origin in the middle, and then you move wherever it tells you to move. Back 4, up 0. Up 0 means I just stay right there on the axis. Back to up 2. And then over 0, so I'm going to start at the origin. I'm not going to go over it all. I'm just going to stay right there. I'm just going to go straight up 4. So I'm on the y-axis. What do you notice about those points?
They made a straight line.
You're right. So now we kind of connect them. That's kind of straight, I guess. And we put little arrows at the end because this will keep going forever. I mean, theoretically, I could put any number I want for x. The domain goes from -infinity to +infinity. So I could put in a 1. It's not over here on the table, but if I wanted to put a 1 in, I can do that. It's independent. I can put whatever I want in there. So I could do y equals 1 plus 4. What would the output or answer be? It would be a 5. And if I put that on a graph, I put in a 1, so I went over by 1, and then up by 5. What do you know? It's right there on the thing. So that's kind of a neat thing. I know you know how to make a line, but why do we make a line? Because this shows me for this equation all the infinite number of input-output pairs without having to do the math, right? Like, I already know, I don't have to do the math. I already know that if I put a 2 in for x, I'm going to get an answer of 6 because it's up 6 right there. Like, it's just on whatever's on the line, those are the input-outputs that are going to fill up this table if we keep it going. Does that make sense? No? Okay, cool. Fractions or division problems. You can do that, right? Like parentheses 3 divided by 4. And then parentheses, whatever your x value is. And then -2. And that's a -5. That's my output. You can do that, right?
Yeah!
Hopefully. I do want to show you one more thing real quick. I guess 2 things. We'll go fast. This gets people in trouble a lot when you have a -x as the function. So, hold on. You need to actually know this. So, alert. Something you actually need to know. If you're not listening because you're listening to rap music or something in your earphones and pretending to listen, and I'm going to probably say something to you and you're going to be like, I'm reading the closed captions. I'm going to be like, there are no closed captions. And then just here's something you need to know. Because this is a thing that people make mistakes on, especially smarty McSmarts like you. You're smarty McSmart. That's encouraging, I hope. This is a -x. So if I'm going to plug in another negative number, don't let this negative disappear. The best way for me to explain this to you so that you never make a mistake, like do this every time, it'll always be right. Just write down exactly what you're looking at. I'm looking at a negative, so I leave the negative. See how it has to stay there? And then when you plug in your new value, that x, that's where you put it in parentheses, and it's a -3. So I put a -3, and then I put the +1. So see how in this case, the negative x, if x is also negative, like the number we're putting in is negative, then it's going to be a negative x. A lot of people just like let these two things become the same thing. They just merge them together. You can't do that. So this is like a -3, which, you know, these cancel out, and it's really just a +3 plus 1, which is 4. So just be careful whenever there's a negative in front of like an x as part of your function. This is getting really messy, sorry. Again, if I put in a -1 here, y equals negative, parentheses, -1 plus 1. So that's really the same as negative makes a +1. You type in your calculator, it's all good. And then the rest of them are a little bit more simple, but again, just leave it there. Like a 0, a -0 is just a 0. So I'm just going to do it over here. If I was actually writing this out by hand, I would do y equals negative parentheses, because I always leave that negative there. Don't let it disappear. But this time I'm inputting a 0, and then I leave the +1. -0, well, that's the same as 0. So that'd be a +1. And then if I'm plugging in a +4 right here, let me do it up there. This would be y equals negative, leave the negative symbol. And then what am I putting in for x? A 4, and then a +1. So this actually becomes a -4 plus 1, which is a -3. When I was in school, my teacher used to make me call these opposite signs instead of negative signs. And this is why, because really this is saying the opposite of x. So whatever you put in for x, this is going to do the opposite of it. So if I put in a -3, well, it's going to change to a +3. And if I put in a +4, well, this is going to change it to a -4. Does that make sense? Just be careful on those little negative things. Last thing, domain. So this is asking the exact same question, but instead of giving you a table, it gives you a list of the domain. Remember, domain x values, range y values. You may want to actually tag this in here. Remember what we said earlier, the output values are the range values. These are your answers. Why does the word answers have a W? Would you like to know? I don't know, so you may never know now. I'm sorry to get your hopes up. I know you're excited. I have no idea. It's weird. But thing that matters, range or y values, these are your answers. So this is just saying, okay, here's your function rule or equation. Here's your domain. Remember, domain, that's your x values. So you have 3 separate x values. We have to account for all 3 of them. X could be 4, x could be 6, x could be 8. So that means we're going to have to do 3 separate trials. If we start with x equals 4, that means I'm putting a 4 for x. Oh, this is color-coded. This coordinated or whatever. This is cool. See that? See how the x changed to a 4 because it's blue? Ah, amazing. My answer would be a -1. And then I go, so I did that one. Check. Now I do it with 6. I'm going to keep this going because I'm proud of it. Y equals 6 minus 5. Yes, you should put these in parentheses, I guess. Whatever. It's all good. What's 6 minus 5? Well, it's 1. Because if you had 6 cookies and I took 5 away, you'd still have 1 left. So you don't need to cry. You're fine. -1, +1. And then the last one, check, is x equals 8. Again, -5, that's the function, that's the equation, that's the thing we're doing every time. That's what the machine is programmed to do. If you had 8 cookies and I took 5 away, well, you'd still have 3 of them left. That's a bunch of cookies. Count your blessings. Don't complain because I stole 5 of them. Actually, you should complain. That's a crime. So think about what happened here. We had 3 separate inputs. So we got, as a result, 3 separate outputs or y values or answers. So the actual answer to this would be, I would put it in set notation just to keep it fancy. It's like if these are the three inputs, what are your three answers? My first answer was a -1. My second answer was a +1. My last answer was a 3. That's how I would write it, like that. And then I put an X. I put a check, not an X, because it's right. And that's amazing. That's good enough. All right, bye.
Wow, Mr. Ellis, that was one of the greatest math lessons I think I've ever experienced. This is so great and wonderful. Thank you so much. This is amazing.